Here we have a couple of for loop examples for you to try and get used to MATLAB. So before you view me covering this example, maybe you could give it a try and see if you can get the for loop to work. Hopefully that will help you learn through the mistakes that you made how to create a for loop and use it effectively. So in this example, we want to do similar work to what we did before, except for we want to use a for loop to make our code more efficient and to prevent us from writing line by line an operation. So in this example, we want to create a y vector which is equal to the exponential of the x plus the natural log of z. And here we can see that our vector x is the value 0 spaced by 2 to 100, and our vector z is 1 spaced by 2 to 101. And so we're supposed to write a for loop to calculate y with special notes on what are the limits of the loop index. So we'll bring up an M file. I'll create a new M file. You can click this button here to create a new M file. And I'll save this immediately in my current directory as for loop try it 1. Okay, save. So start our M file with a clear and declare this x vector x equals 0 by 2 to 100 semicolon, z is 1 by 2 to 101. Okay. So now we're ready to write our for loop and perform these calculations to store it in a vector y. So the for loop starts with a for, and you can notice that MATLAB immediately highlights it blue because this for is a special keyword. MATLAB knows that you're trying to write a for loop. I like to use the loop index or the loop counter variable named I. It's probably the most common. So for I equals 1 to okay, so we want to loop through each value in the vector x. So we need to know how many elements are in the vector x. This may not be too intuitive to new students, so let's examine this. Let's comment out this line and run this code and see how many values are in x and z. So I'll run this code and I'll look at my command window. Okay, we still have this error from this previous example, but we can see x and z are in the workspace, and we can see it tells us that these vectors are 51 elements long. So if we look back at our declaration statement, we see 0 by 2 to 100. So if you think about this, hopefully you can prove to yourself that there should be 51 elements in this vector. So back to our for loop example, for equals I equals 1 to 51. We want to loop 51 times. We can give a couple spaces and end. Okay, and then inside our for loop we want to store our values in the vector y, and we want to use our loop counter to index our vector. So y of I equals the exponential function, and then in the exponential function for yi we want to take the exponential of x of I. Then we want to add the natural log of z of I and suppress the output with a semicolon. Okay, and this is the solution to this triad. And so the most important thing to note is using this loop variable as an index for these vectors. Okay, so we can execute this code and examine the contents or the results. Uh-oh, we had an error. ln is not a function. It must be log. So this isn't the function name. The function name is log. And then we can try and execute the code again. Okay. So I didn't type a CLC at the top of my program. That's why the screen wasn't cleared. But we can see the results from executing our code. X is 51, Z is 51. I at the end of the code as after it increments 1, 2, 3 all the way up to 51. At the end, I is still has a value of 51, and then we can see y is a vector 51 elements long. And we can see that the exponential term dominates, 51 elements long. Okay. So this is the first for loop try it example. The second, if you have time, I strongly suggest you understand because it is important to your homework problem number 4. And this basically what this for loop problem is trying to have you do is sum up the values from 1 to 100. And again, the solutions are posted at the end of this. Here we can see this example. So to the next topic, MATLAB has a special file called a .mat file. Okay, it's just like a .doc file for Word. It's a .mat file that is specific to MATLAB. And what these mat files are is a saved workspace with variables. So you can save your workspace and load it later at a different time. And so here's a little example. We have a paycheck.mat file at Learn at UW that we can access. So I'll go to Learn at UW in the content. We can see this paycheck.mat. I'll click on it, download file. I'll save this file to our current directory. So I'll go to my desktop, CE291. Okay, save paycheck.mat. Save. Close this window. If we go back to the MATLAB command window, we can see in our current directory we should see this paycheck.mat file now. We can also see our other M files that are saved in our current directory. Using curly brackets. So I think the example has us do it from the command line. It does. So from the command window, we can clear our variables, clear our workspace. So clear it. We get nothing in our workspace. And what we can do is load, and then in quotes, paycheck.mat, and watch the workspace. We can notice paycheck.mat had a vector hours and a scalar value wage. Okay, so this must be 5 different workers who work different hours, and their wages is 20. Okay, so you can load these mat files and then use these variables. So now I can say hours value 1, which is 32, times wage, and we can do work with these variables. So mat files are a nice way to save your workspace and pick right back up at a later time. The next thing we want to cover in MATLAB is critically important and is just as basic as for loops. The if-else statements. These are very similar to the ones we use in Excel, except for we just have to follow MATLAB's syntax, just like the for loop. So the if statements in MATLAB are similar to the for loops in that they're contained in this if-end block. So you start an if statement with if condition, and then you enclose some contents, and then you end it with this end statement. So let's look at this MATLAB syntax. Just like I said, you start with the if, and then enclose in parentheses a condition. Just like in Excel, x is less than 4, x is greater than 6, x equals 5. And you can see the conditions that you can use in MATLAB on the right here. And particularly important is this equals. You do not say x equals 5. Your condition must be a double equals, x equals 5, and that will compare x to 5. X is less than, less than equal, greater than equal, and then not equal, you use this tilde. Okay, so after this first initial condition, if you meet this condition, you can write your statements here that you want to do, and then after that you can say else if it didn't meet this condition, you can have another condition, and then inside that you can do some other computations. And then if it doesn't meet these first two conditions, you can just have an else statement for everything else, do these computations if it doesn't meet these first two conditions, and then end. So let's look at this example together. It's similar to the example of calculating a weekly paycheck for workers who work so many hours at a certain wage. So let's copy and paste this to an M file. So we'll create a new M file and save it as, we'll call this paycheck.m. Okay, and we'll paste this, and we'll space this out a little bit so we can see what's going on here. Okay, so the first line, and actually we should start with a clear, so we clear all the workspace, and the second command here then is load that paycheck.mat file, and we can look at, I believe I still have it in my workspace. Yep, so we load this paycheck.mat. We can see that we have this hours vector and a wage scalar. So we can use that in our M file program. So we go back. So load paycheck.mat creates or reloads vector hours and scalar wage. So then we can use those. So we start with our first if statement, if, and then hours, and then we'll just, for this example, access the first value in the hours vector, so we'll always use hours 1. So if hours 1 is less than or equal to 40, the total would just be wage times the hours worked. Okay, so if it's not less than or equal to 40, it will check this condition, say no, and it'll come to this else if block, and we'll evaluate these conditions. If hours 1 is greater than 40, and then if you want another condition in this else if, you do this double and. So if it's greater than 40 and hours is less than or equal to 60, perform this calculation, which is the equation to calculate time and a half. Okay. If it's not less than 40, not greater than 40, and less than 60, it'll come to this else statement where we display nobody works that much. And copying and pasting from PowerPoint, the quotes don't seem to work or copy correctly, so you need to delete those and just enter that single quote. So we can execute this code. We'll go back to our command window and see what is printed out. Attempted to execute. Oops, we did not enclose paycheck.mat within quotes, so I have to come back here. Load paycheck.mat needs to be within these quotes so it knows it's a string. So we can retry to execute this. And go back to our command window. Okay, and we can see we didn't print anything off to the screen. We suppressed the output. We can see total is 640, and we calculated this value based on the first value in vector hours, which is 32, which is less than 40. So total should just be 32 times the wage, which is 640. So total. So this is correct. So now we can edit this to see perhaps what happens when we use hours 3, which is 55. So in this code, we need to, instead of access the first value in the vector hours, we want to access the third value. So we need to change all these to hours 3. Hours 3. And we can re-execute this code, and we should expect it to execute this equation. We look back, total is 1250. We did print out this line. Okay, and you can check the math on that if you want, if you don't believe that it performed the code correctly. So lastly, we can check 67. So that's in vector spot 5, hours 5, hours 5, hours 5. Okay, and execute, and we should expect it to skip these two statements and print out nobody works that much. So execute the code, and we look, nobody works that much. So seems that this is working correctly.